Hi, my name is Marcy Baranski. I'm talking today about agroecology and small farmers, and mostly about agriculture in developing countries and the relationship between that and sustainability and food production. This is a short talk. It's intended for an audience that does not have a technical background in agriculture, so maybe like an undergraduate level student or just anyone interested. So, as I start this discussion today, I want you to think about two questions. One is, can we farm in a way that is sustainable and that also benefits small farmers? And two, what kind of science and technology do we need to get there? The outline of this talk is first to talk about the Green Revolution and its consequences. Second, to talk about smallholder farmers, who they are, how many are there. Third, two competing visions for agriculture in the world. And three, I will talk about these three concepts of sustainable intensification, conservation agriculture, and participatory research. So this talk is based on my own research leading up to my PhD, which was really focused on the history of the Green Revolution and the consequences of that, and also an article that I wrote for Issues in Science and Technology with my co-author, Mary Allenberger, who's done extensive field work in Africa. So I'll include a link to that article in the YouTube video description. So let's start with the Green Revolution. This is really the foundation for modern agriculture and agricultural research, especially in developing countries. So the Green Revolution really started in the 1940s when the Rockefeller Foundation was investing in agricultural research in Mexico. They brought several American scientists into Mexico to study why agricultural production was so low there. There were issues with pests, there were issues with yields. And so the most known of these scientists is Norman Borlaug. He's an American scientist who, working with other researchers around the world actually, he developed a new variety of wheat that is called semi-dwarf because it is a shorter variety of wheat, which means that it could handle larger amounts of synthetic fertilizers. This was something that was fairly new in developing countries using synthetic fertilizers, and Borlaug realized that if farmers did use these fertilizers on the taller varieties of wheat, they fell over because the grain became too heavy. So once he heard about these shorter varieties, he started breeding with them, and he was also breeding in disease resistance. And then coincidentally, he also found the trait of photoperiod insensitivity. He wasn't actually the person that discovered it, but he was maybe the first person to realize that these wheat varieties that he developed could be grown not just in Mexico, but in many, many places in the world. And typically, this is not the case. Usually, a variety of a crop can only be grown in a certain area. But because of the specific properties of wheat and this photoperiod insensitivity and ability to apply large amounts of fertilizers combined with disease resistance, this wheat became very popular around the world. Governments were promoting it heavily because it increased the production of wheat in these areas. Now, this model was also used for maize and rice. I would say not as successfully, partly because these crops don't have the same photoperiod insensitivity and adaptability that wheat does. But nonetheless, a lot of the modern varieties of maize, rice, and wheat are based on this research originating in Mexico and research that's happened since then by the same organization. So the takeoff of these varieties and using new fertilizers really happened in the 1960s and 70s, obviously decades after that research had started. And it definitely coincided with the use of synthetic fertilizers. Again, this was heavily promoted by governments And something I want you to take away is that the Green Revolution wasn't just about releasing a new technology in the world and farmers adopting it. It was it coincided with massive government investments to allow farmers to adopt these technologies, and also changing policies so that farmers who are growing these staple crops of wheat and rice and maize would also have a good market and receive good prices for these crops. There was also other economic changes, such as giving farmers loans in order to buy these more expensive seeds and fertilizers, investing in irrigation. And this coincides with one of the criticisms of the Green Revolution, which is that it really only benefited large and wealthier farmers. And this actually was one of the initial intentions of the Green Revolution. It wasn't meant to help all farmers equally, it was meant to improve food production. And the scientists and administrators thought that the best way to do that would be what they called betting on the strong, or targeting larger farmers who had access to irrigation and who could buy fertilizers. So, production did increase, use of fertilizers did increase, but we'll talk about in a minute the effect on smallholder farmers. So, as an effect of this increased use of new varieties and synthetic fertilizers, we definitely had higher yields of wheat and rice and higher production, which is just the overall amount that is grown and harvested. And Borlaug was not much of an environmentalist, but he argued that without the Green Revolution, we would have needed a lot more land for agriculture. So this would have meant cutting down forests or plowing up grasslands and turning them into cropland. So while this is debated, it's something that we're going to circle back around to, which is how can you produce more food without taking up more land for agriculture? You need to somehow increase the yields so that you're getting more food out of the same area of land. So I've mentioned a bit about the negative consequences and that the Green Revolution primarily benefited larger farmers. And this is because, like with adoption of any new technology, whether it's a new phone or a new type of laptop or something, it is going to be wealthier people who have more resources, who are the first ones to adopt these technologies. But further than that, in agriculture, one of the challenges is providing something that can reach a large amount of farmers, but that it is also tailored enough to their specific conditions. So I like this quote, which is that one of the main criticisms of the Green Revolution is that it attempted to provide universal solutions to problems that needed regional and local attention and flexibility. So you will see from both my talk today and my article in Issues in Science and Technology that I do agree with this, and we'll get into that. So some of the agroecological problems or environmental problems of the Green Revolution have been heavily discussed. These include soils becoming degraded because the more crops that you're growing, or you may be growing two crops in 1 year, you're taking more nutrients out of the soil. Even though you're adding nitrogen, you might be taking carbon and other nutrients out. With all of the irrigation, there's a problem of groundwater depletion and leading to that groundwater becoming salty or salinized. In some places, there were problems of increased pests because where there is more food, pests are also attracted to that food. And then because of adding a lot of fertilizer, well, this is needed to increase yields. This fertilizer can run off into waterways and have problems there. It also is a greenhouse gas. Nitrogen fertilizers turn into nitrous oxide, and so that's a greenhouse gas. And then finally, because the Green Revolution started with just a few varieties, there was this loss of agricultural biodiversity. in that farmers were growing a more larger variety of traditional crops, and a lot of both these crops and the knowledge about how to grow them has been lost over time. So the other main criticism of the Green Revolution is that it has caused social inequity by really targeting the larger farmers, that small farmers were not able to benefit from this. Now, there's been a lot of discussion about this. Some economists say that, well, if food production is increasing, then that means there's more, say, labor jobs available for small farmers. Also, food production is increasing, then food prices should be going down. But I would say the social science literature does not have a lot of clear answers, but that most of it points to this is correct, that inequity was increased because of the Green Revolution. So one of the issues around these, broad solutions, universal solutions, is that when scientists are testing something, they're typically testing it under what they call the ideal conditions. So these aren't necessarily the conditions that are in farmers' fields, especially small farmers who are dealing with a lot of challenges, typically things like uneven terrain or not having access to irrigation or all of the other inputs like pesticides, herbicides, and fertilizers. So the varieties that the scientists are testing in their research fields, while they may perform well there and have a high yield there, they may not have a high yield in a small or poor farmer's field. And additionally, these farmers might not want the same things that the researchers thought were you know, the way to address problems. The farmers may want something rather than having a really high yield under good conditions, has a more stable yield under all conditions, including droughts or flooding or heat. And farmers may also be looking for things like taste, cooking properties, and the storage or like shelf life of these varieties. So scientists aren't always considering that, and so that may be one reason why small farmers were not adopting these varieties as much. So let's talk a bit more about who are these smallholder farmers. So these are farmers that are growing food on less than 5 acres of land, and there are over 2 billion of them. It's hard to get an exact amount, but this is what scientists estimate. And they make up over 80% of global farmers. So there really are quite a lot of smallholder farmers, and they do make up perhaps not a majority, but a lot of food production. So these farmers are often poor, and they're often living and farming in more diverse ways than, say, a wealthier or commercial farmer. And this makes them difficult to target using traditional agricultural outreach programs, which are usually associated with a company or a university or a research organization. So I and others argue that if we do want to continue this Borlaug hypothesis of producing more food without putting more land into agriculture, we really need to reach these farmers. And I want to say that I'm not saying that these farmers are currently farming unsustainably. I think that they are very innovative, doing what they are doing with what they have, but there is a fact that they are resource constrained, and this can sometimes lead to non-optimal conditions. For example, using a lot of land, or 5 acres or less, but using this land and not getting great yields. So that land may be being degraded, and it's not because of these farmers are bad farmers, but they are just constrained by often being poor or farming on a hill or something where erosion is a greater concern. So we really need to also consider the poverty dimension of smallholder farmers. And while we need to raise yields in order to increase production, this does not necessarily help them get out of poverty. So scientists have found that typically farmers need a few different pathways in addition to raising yields to get out of poverty. And this may be taking a job that's not related to agriculture. It may be purchasing more lands, which was an option perhaps earlier, but now with the population increase is no longer an option. There are certain ways that farmers could diversify what they're growing, such as investing in higher value crops or trees or livestock. But consider one thing about high yields and agriculture and poverty, and that is that in the United States, we have some of the highest yields in the world for crop agriculture, for dairy agriculture, and farmers are still often on the brink of bankruptcy. So it's not just yields that's controlling a farmer's income, it's the cost of the various inputs, things that go into the farm, but it's also economic conditions like trade, like the cost of labor. And so I just want to leave you with this that increasing yields is not necessarily a way to improve these farmers' livelihoods. So we need to consider the multiple dimensions around smallholders farmers' livelihoods. So in thinking about how to feed the world, how to farm sustainably, people tend to fall into one of two camps. One is to continue the Green Revolution vision. This is investing in these high-yielding staple crops, such as wheat, rice, and maize, using high amounts of chemical and mechanical inputs. And typically, the scientific methods to get there are focused around plant breeding and increasing the amount of fertilizers, and these sort of technological solutions that you can scale to a larger population or a larger area. An example of a group that is very much promoting this method is the Alliance for the Green Revolution in Africa. This is sponsored by the Gates Foundation, by various governments, and it's really based on this technology-focused, fertilizer-focused paradigm. But they also do recognize the equity problems with the first Green Revolution, but I would say have not really adequately addressed how their vision will differ from the first Green Revolution, because what I talked about is that when you're introducing a new technology, naturally the first ones to adopt it tend to be these better off farmers. So I think that the Alliance for the Green Revolution in Africa is definitely a noble cause, something maybe you didn't notice, but the Green Revolution never really took hold in Africa. This is for a variety of reasons, and so they are trying to, improve yields in Africa. I'm going to spend a lot of the next few slides talking about Africa because this is one of the areas that a lot of international development is focused on, which is not to say that in other areas of the Green Revolution, like South Asia, that things are going perfectly. There's still a lot of poverty and hunger in these areas, but Africa is definitely the site of a lot of intervention right now. So further criticism of the Green Revolution is that farmers are too reliant on these external inputs such as chemicals and labor, and this makes them vulnerable to things like an increase in price of something like a fertilizer or fuel for their machinery. But it also, because they tend to be growing only one or two crops, they're also very sensitive to price shocks in terms of maybe the price becomes very low or say the price for animal feed becomes very high. So it's criticized as not being as resilient to things like environmental changes, economic changes, that kind of thing. So really the opposing vision to the Green Revolution is agroecology. This is more of an integrated approach that considers the social and environmental aspects of food production. It seeks to provide ecosystem services through agriculture, which means that an ideal agroecological landscape would not just be one crop, but would probably be multiple crops would have habitat for pollinators, would have some forested areas that also provide soil benefits and further habitat. And on the flip side, though, this approach is criticized as really romanticizing the small farmer, romanticizing farmers who are poor and keeping them poor. And the opposing side would argue that maybe these small farmers shouldn't be farming. Maybe they should go into other occupations, and that the best way to produce food is really through the Green Revolution approach. So another challenge of the agroecology vision is that it requires a lot of tailoring to specific contexts. So there's really not one solution that you can universally apply. Now, I would say there's definitely middle ground between these two approaches. So some people might see them as the Green Revolution being really pro-genetic modification, and then agroecology being only organic, but it's really not that clear cut. Farmers tend to adopt things that work for them. And so I think the lines between organic and GMO are really too black and white. And between these visions, that there probably can be something that's more of a middle ground. So one proposed path forward, it's taking a bit from both of these approaches, and it's called sustainable intensification. So the idea behind this is that you can improve yields while also reducing the environmental impact of farming. So this has become an idea starting around the 1990s. So it's been around, 30-ish years. And it's really become a mainstream goal of governments, of development organizations, and other research organizations. So the goal, again, is to, increase the amount of food produced without expanding the amount of land needed for agriculture, similar to the Borlaug hypothesis. The drawback, though, is that it's a goal and there are no real specific methods associated with sustainable agriculture. There's not even really a unified theory. Like with agroecology, there has been a lot of theorizing around what is agroecology, what is an agroecological approach, but sustainable intensification really doesn't have this sort of theory. And then the concept of sustainability itself can be vague, and there are also multiple aspects of sustainability, and this framework does not provide any guidance on which ones to prioritize or value. So for example, do you want to prioritize water quality or biodiversity conservation when you're planning out the ideal farming system for a certain area? And there's no sort of guidance here. Nonetheless, it is very popular, and there are a set of practices that have started to come out as forms of sustainable intensification. I'm going to talk about a few of these. One of them is called conservation agriculture. So this is Dr. Ratan Lal. He won the World Food Prize in 2020, which is the most prestigious prize in food and agriculture. Dr. Lal grew up in India, and early in his career, he moved to Nigeria to work on soil erosion, which is a large issue in African agriculture. So soil erosion is caused by deforestation, it's caused by agriculture, and just the specific climate conditions of the region. And Dr. Lal helped establish the importance of soil carbon and building soil carbon as a solution to soil erosion, and he helped to develop a toolbox of techniques that are called conservation agriculture. So the idea of conservation agriculture is really to build up the soil carbon and improve soil structure as a way of reversing this soil degradation. So the concepts behind conservation agriculture are to keep the soil covered, first of all, by either growing something and not letting the land just sit bare. Second is to minimize the disturbance of the soil. So this means not plowing or minimizing the tillage. So this is called many things. Could be no-till, zero-till, minimum till, conservation tillage. These are all related to conservation agriculture. And third is to diversify the plant species that are actually grown on the land. So this is done using crop rotation. The other practice associated with keeping more of a cover on the soil and improving the soil carbon is by not removing all of the plant. So usually farmers would remove most of the plant after it's grown, and then they would use these stalks and stems for things like animal feed or firewood or fuel. So in conservation agriculture, it promotes leaving more of this on the field, and this breaks down and helps build up the soil carbon. So these practices and the ideas around conservation agriculture have been heavily adopted in North and South America, Australia, Asia, Southern Africa to much success, though it is typically adopted by larger farmers for a variety of reasons. But international donors and governments have been promoting these practices to smallholder farmers in Africa, often viewing it as a universal solution or panacea to the soil degradation and fertility problems in Africa. However, some scientists have been arguing that conservation agriculture really isn't appropriate to the socioeconomic context of these farmers who have been reluctant to adopt conservation agriculture. So there's been really low use of it among smallholder farmers in Africa, although in, say, South Asia, it's been easier for farmers to adopt. So a recent paper, scientific paper, they did a meta-analysis of 79 studies that were done in Africa. This was across 16 countries, and they looked at all of these studies of conservation agriculture. So what they found is that implementing conservation agriculture improved yields in maize by 4%, but not significantly for other crops. And 4% is not much of an incentive for a farmer to go through all of these changes that are required for conservation agriculture. It requires more labor, it requires specialized tools, it can bring more weeds into the field, and they might be wanting to use those straws and those stalks as animal feed or as fuel. So here's an example of like a new machinery that's used. Since they're not plowing the soil, you need something to help the seeds get deeper into the soil. So another reason why farmers might be less likely to be interested in conservation agriculture is the crop rotation aspect. So typically rotating a crop, maybe you're going from something like maize, which is really fertilizer heavy and extracts a lot of nutrients from the soil. And then the next year you plant a legume, which is like a bean or a lentil, and legumes actually return nitrogen to the soil. However, in Africa, there's not a lot of market incentives to sell legumes, so they have lower prices and farmers are not as interested in growing them. So while conservation agriculture has been greatly beneficial in other contexts in other countries, unfortunately, it is more and more looking like it's a small fit for the smallholder farmers in Africa. However, this leaves us with a question, which is that Africa does have degraded soils, and this does need to be addressed if we do want to get better yields there and intensify agriculture. So the question is, should organizations keep promoting conservation agriculture? And if so, how can they consider issues like labor availability, access to machinery and herbicides, and improving the marketability of legumes? None of these are really technological problems. They are social, economic, and political problems, but it is very difficult to go into a country and to try to address some of these. And I would argue this is the reason that development organizations are often more focused on these technological solutions. So, some people have suggested that a way to better reach smallholder farmers is to really talk to them directly and find out what their needs are. And surprisingly, this has not been the way that agricultural research has traditionally operated, especially in developing countries. So, one step further from actually talking to farmers, especially these small farmers, is to actually involve them in research projects, such as having them plant new varieties that you're working on, or test new technologies and give their feedback. So, this is called participatory research. It can be more time intensive and expensive to implement. So it's definitely not something that is popular, but it is a great way to understand more about smallholder farmers and what are their needs and capacities. Participatory research also emerged as kind of an alternative to the Green Revolution style research and has always been specifically focused on more working with smallholder farmers or understanding the diversity of conditions that farmers are working under. So Dr. Sieg Snap, who is a scientist at Michigan State University, has been working on participatory research specifically for sustainable intensification. And I like how she says, to me, process is as important as outcomes. I work to build capacity for farmers by providing options rather than one-size-fits-all silver bullets. I think that's the only real, lasting kind of agricultural transformation. And Dr. Snap has lately been studying pigeon pea in Malawi, where she's worked for a very long time. So pigeon pea is a shrubby legume that can be grown for multiple years. Most crops are only grown for 1 year, like maize, wheat, and rice. So being something that's grown for multiple years is called a perennial crop. And further, pigeon pea is a legume. So having both of these properties, it's really a good way to improve the soil fertility of degraded soils. And also because you can see in this picture how tall it is, there's a lot more plant material that farmers can later use as firewood and fuel. So Dr. Snap has studied how farmers are growing pigeon pea and testing new varieties and new techniques using participatory research methods, which is how she actually learned that farmers wanted to grow it for more than 1 year. So most scientists assume that farmers want to grow what are called short duration varieties, which are varieties that need a shorter amount of time to actually reach the harvest level. But she found that farmers actually wanted to be growing it for 2 or more years, and that scientists should be working more on these longer duration varieties. So Dr. Snap has also developed a participatory research method called the mother-baby trial. It's kind of a funny name, but the idea is that researchers still get to do their traditional, using their ideal conditions and testing a variety of hypotheses and variables. They still do that, but then they engage with a variety of farmers of different socioeconomic statuses and different environments. And these farmers are testing 1 or 2 variables at a time. And then there's also the built-in variable of just different farming techniques, different environments that they're growing in. So this method has really allowed researchers to test these technologies over a greater number of farmers and also a greater number of environments, and has helped researchers, become more innovative in working with smallholder farmers. And it also means that the smallholder farmers are more likely to adopt the technologies that the scientists ultimately decide to release. So that's the end of the content of my PowerPoint. I want to leave you with a few points. One is that technologies and the process of developing technologies or innovation is not a neutral subject. There are a lot of decisions that need to go into what is studied, what kind of people have input or who have power over the study. And so it really is a political decision whether you are in a government or a scientist working in a lab. The things that you're working on are ultimately decided by decisions, and often these can be political decisions. The other is that technological solutions, like I said, they're often more appealing because they're a way to get around these sometimes necessary social, political, or economic changes that are needed. I would say technologies they typically reproduce the environment that they're released in. So they're not usually something that's like some great equalizing factor or some great democratic technology. I would say an exception to that may be something like cell phones, which, while at first only wealthier people had cell phones, now, I've heard like there are more cell phones than toilets in India. Really, almost every person has a cell phone, and this actually allows them access to like a lot more information. But I would say that may be a rare case, and especially in agriculture, there aren't usually these kind of silver bullet solutions. Solutions often do have equity problems or unintended consequences, whether these are social or ecological. So, yeah, I hope that this has given you something to think about. I hope what you realize is that there aren't a lot of easy answers in agriculture, especially in smallholder agriculture. It's often the case that everything has a trade off, that if you get something that has a more positive aspect somewhere, it has a more negative aspect somewhere else. But regardless, I think it's important to keep trying, to keep working with smallholder farmers, really in order to improve their livelihoods and improve the food security of poor people around the world. So I hope that you enjoyed this talk. Please feel free to get in touch with me through email, through Twitter, through leaving a comment. I'm definitely interested in your feedback, and I'm happy to answer any questions related to my research, or maybe try to put you in touch with the right person. So thank you very much. Feel free to use this for educational purposes, such as using in a lecture or assigning as part of a syllabus. Thank you, and yeah, get in touch.